Here we go with some integral word problems, everyone's favorite. So we find out that my velocity on a trip was given by v of t equals 10t minus 2t squared. So let's kind of talk about this a little bit. So what does this equation look like? What does it mean? Well, it's telling me that my velocity starts off at 0. If you plug in 0, you'll get 0 out, and it goes up. It actually ends up kind of being a parabola, and then it comes down. So I start off the trip by traveling a little bit slow, get faster, 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 and then I slow down. And so it says, using an integral, what was the distance traveled in the first 2 hours? And so what does that mean? What does that mean? And so what we actually find, and what we'll be using in this section, is that when you integrate a rate, and this is something we've already talked about a little bit before, when you integrate a rate from a time equals a to a time equals b, what you end up getting out is your total change between t equals a and t equals b. And so what that means in this case, here, this velocity, this is my rate. And the distance traveled will be my total change. So you can kind of think about the rate. What is the rate referring to changing? Well, it's talking about your position changing, right? So that is your total change. And so when we write this as an integral, what we want to do is we want to write the integral, and we want to start with our first time. It says in the first 2 hours, so we start at 0, and we go up to 2, and we're going to be integrating our rate. We're going to be integrating 10t minus 2t squared dt. And so that's all that we want for a. Represent the distance traveled, represent the total change using an integral. And so the question is, this thing here, this is actually just a number, right? So maybe I traveled 50 miles. Maybe this thing's equal to 50. How do I find out what that number is? So one way I could do it is by just typing it into a calculator. We could use the great FNINT button, and if we typed it in there, it would tell us that it would actually just tell us the number 14.666. What does this number mean? Well, this is my total change between t equals 0 and t equals 2. So this is actually my total miles traveled. It's the thing that's changing, right? The distance is what's changing. And so I traveled 14.66 miles. Now, how else could I do this? So this is, I use a calculator. I found this integral. I found that FNINT of that was 14.66. But how about down here? So I've rewritten the integral. And here what we're going to do, rather than finding it exactly, so the calculator comes up to 2, and it says, I'm going to find the exact area under this curve between t equals 0 and t equals 2. Now, another type of thing your book is going to ask you to do, rather than finding this area, it might say something like, well, let's approximate it, right? So let's go up to 2 again. But rather than find that exact area, I'm going to do something kind of a little bit silly. I'm going to make your life a lot harder. I'm going to draw 4 rectangles, and I want to approximate the area. This area using rectangles like this. So specifically when it says left rectangles, the height of your rectangles is the height of your left endpoint. So the rectangle that goes between t equals 1 and t equals 2 only goes as high as this left endpoint. So that's my area from that first rectangle. Now the second rectangle only goes as high as that left endpoint, right? And so you'll get this is a rectangle. This last one goes as high as this. And notice that that first rectangle, the left endpoint, is at 0. So the left triangle it's kind of like just a thick line here. It's flat though, right? And so if we need to approximate it using 4 subdivisions, what we do is we just add up these 4 areas. We add up A1, A2, A3, and A4. And so to do that, all we do is we use the equation for the area of a rectangle. And so the area of a rectangle will always be base times height. The base of each of these is 2 divided by 4. So 2 divided by 4 is equal to 1/2. So it'll be base times height, so 1/2. And now the height of the first one is 0. What's the height of the second one? Well, the height of the second one, I'm just going to write down, I'm going to call this thing f of t for now. It's actually just going to be f of 1/2. The third rectangle has a base of 1/2. It has a height of how high the function is at this point. This point is 1, so it's times f of 1. And then the last one will be 1/2 times the height of the function at this point, which we can see is 1.5. So that will be f of 3/2. Now if I go through this whole thing, a1 multiplies out to be 0. And the rest of these I'm going to do in my calculator. So f of 1/2 is 4.5. F of 1 is 8. And f of 3/2 is 10.5. And so if I actually type this whole thing out, I will get 11.5. So what is this 11.5 again? Well, this is an approximation of this thing, which is an integral of a rate. So this is my total change. So this is 11.5 miles. So 11.5 miles is kind of close to the actual exact answer, right? So the calculator told me the real total change. It colored in this whole area. This approximation here, which we actually can do, is kind of close to the total change.